Hello, good people. Let's talk about large-scale analytics. In the last decade, we have seen a major paradigm shift in the scale of data that traditional companies are actually processing. By traditional, I actually mean companies that are not Google, Facebook, and Amazon, who are known to process and produce insane large amounts of data. So where does this so-called big data actually come from? According to the latest big data trends, typical and common sources are as follows. Social media. These are your likes, tweets, retweets, and comments you typically post on social media. Machine data. This is information generated from industrial equipment and sensors which are installed in various machinery. Such examples are medical devices, road cameras, and satellites. And this is a whole concept on its own known as the Internet of Things. Transactional data. This is data generated from all your daily transactions that takes place online or offline, such as payment orders, storage records, and your delivery receipts. So this influx of data has created the need for companies to draw insights in order to gain a competitive advantage. This need to draw large-scale analytics from this huge influx of data has affected traditional means of processing the data. So let's observe traditional tools that were used for data discovery and perhaps why they no longer adequate. Traditionally, professions such as statisticians were commonplace, and they used tools such as SPSS and MATLAB on their own machines to process data. The amount of data that you can process using SPSS and MATLAB is limited to the amount of processing power your computer has. But if you needed to process several gigabytes of data, which are somewhat impossible from your own machine, then your company needed to establish a data warehouse and then use business intelligence tools such as ClickView and Tableau to process and visualize the data. So what is business intelligence exactly? Business intelligence systems are designed to provide a historical to current and predictive views of a business operations. So let's dissect this in simple terms by going through an example. I once worked for a retail company, and we were required to build a business intelligence system known as Just Enough. The system needed to calculate the quantity of products a company should procure for its customers during a particular time period. The goal here is to stock enough products and to avoid or lessen the impact of overstocking items which the company may be forced to sell for a discounted rate. The idea here is that during the summer period, you're most likely to sell more fizzy drinks such as Coca-Cola and Pepsi. And you want to ensure that the company stocks just enough fizzy drinks for the summer period. And these products have an expiry date. And you want to ensure that you do not overstock those items, as you will be forced to sell them at a discounted price when they get closer to their expiry dates, or they will be discarded as a waste item. In order to calculate the just enough items a company should stock over a particular time period, well, you need historical data, perhaps that goes back to about 3 to 10 years ago. And you will need to store this data somewhere, and you will typically store this data in a data warehouse. The data warehouse isn't just a data dumping site, but it's a carefully structured and engineered in the form of data marts to make it easier for reporting tools such as ClickView and Tableau to visualize the data for a particular subject matter and to answer business questions. Data warehouses are typically deployed in a single server instance. However, this may not be enough for very large datasets. And what companies typically do is to set up a large data center with several servers installed that work together to process the data. Perhaps at this point, you may wonder, what is large? It's actually quite scary and terrifying to think that data has grown insanely large in the last couple of years. And this data comes into the business in different formats too, which adds to the overall complexity of processing the data, which renders the data warehouse inadequate to process the data. And to solve this problem, the industry has invented Hadoop and cloud computing to process a big data. So what is big data exactly? Well, we can define it this way. If the data is too big for the processing capacity of traditional database, or the data moves just too fast, or if it doesn't fit your typical database structure, then perhaps we might consider this as a big data. And especially if the size of the data is greater than 1 petabyte at the time of processing. Doug Laney from Gartner defined big data as the following: high volume, which refers to the large size of the data; high velocity, which refers to the speed of the data; high variety, which refers to data that comes in different file formats. So let's get into defining Hadoop. Hadoop was developed under the Apache Hadoop project, which is a software library that makes up a framework that allows for the distributed processing of large datasets across clusters of computers. It is designed to scale the processing of data from single to thousands of machines. And this is where cloud computing comes into the picture. Not all companies are privileged to have thousands of machines to process the data. And even if the company does have that capacity, it can get very expensive to maintain. So, the promise of cloud computing is that you can scale as many machines as you possibly can to process your data using Hadoop tools. And if you have a small data set, you can only pay for a small set of machines to process the data. The point is, you pay for what you use. And that makes the cloud more cost-effective than maintaining a large data center. And this is one of the benefits of using the cloud, and there are absolutely plenty more. And oh, by the way, the cloud is nothing more than the idea of using someone else's data center to store and process your data. The major cloud providers are Azure, Amazon, and Google Cloud. In this lesson, we set out to define large-scale analytics and also take you through the list of tools that are used for a particular use case in order to get some level of context. But it turns out that large just simply refers to data analysis that spreads over the processing to many machines. And perhaps it's about that time where you need to start doing your own research. I would like you to investigate and list other common business intelligence tools that are widely used in the industry. And furthermore, investigate the difference between Kimball and Bill Inman in the world of data warehousing and business intelligence. I would also like you to list the available tools and platforms under the Apache Hadoop project. And furthermore, I would like you to research and list the different file formats that you can find on a typical Hadoop cluster. And also outline the advantages and disadvantages of each. And this is it from me, and I shall catch you on the next one. Goodbye.